Hi, I'm Dr. Ian Van Luton from the Department of Maths and Stats at Curtin University. Let's say you're a caveman and you see a woolly mammoth. For protection, you lie on the ground 45 metres away from the woolly mammoth. You look up at an angle of elevation of 4 degrees and you see the top of the woolly mammoth's head. What you would like to know is what is the height of this woolly mammoth. Problems such as these can be solved by using trigonometry of a right angle triangle. Let's start by looking at the theory. Trigonometric functions are a fundamental tool in modelling and solving many science and engineering problems. Trigonometry can be applied to find the height of an object, the distance between bodies, as well as the rotation of an object. We'll begin by defining the trigonometric functions as the ratios in a right angle triangle. When we say we want to solve a right angle triangle, we mean we want to determine any unknown angles as well as any unknown side lengths. The easiest triangle to solve is a right triangle. So let's consider a right triangle. A right triangle is any triangle which contains an angle of exactly 90 degrees. The way we denote that is as follows. Let's also assume that this triangle contains the angle theta. With respect to theta, we classify the sides as being either the opposite, the adjacent, or the hypotenuse. So, the side which is opposite the angle theta is denoted as the opposite side. The side which is adjacent, that is next to our angle theta, is denoted as our adjacent side. And a remaining side, which is opposite our right angle, is denoted as a hypotenuse. It's the ratio of these three lengths which makes up our three trigonometric ratios. The three basic trigonometric ratios are the sine, cosine, and tangent. The sine of the angle theta is denoted as the opposite side divided by the hypotenuse side. Cosine of the angle theta is equal to our adjacent length divided by our hypotenuse length. And finally, the tangent of that angle theta is denoted as being the opposite length divided by the adjacent length. Whenever you write sine, cosine and tan, you must always associate it with an angle theta. Without an angle theta, it does not make any sense. Also, when we're trying to solve an unknown triangle, to determine any unknown side lengths, it also helps sometimes to use Pythagoras' theorem. Pythagoras' theorem tells us that the hypotenuse side squared must equal to our adjacent side squared plus our opposite side squared. Also, if you're trying to determine any unknown angle within the triangles, it also helps to use the fact that all the angles in a triangle must add up to 180 degrees. So let's return to our initial problem of trying to determine the height of our woolly mammoth. So here we basically have a right angle triangle. What we like to do is determine this side length here, that is the height of the woolly mammoth. So let's let this 4 degrees be denoted by our angle theta. We'll then classify the sides of this triangle. To begin with, this side, which is opposite to our angle theta, we'll denote as the opposite. This side length here, which is adjacent to our angle theta, we'll denote as our adjacent length. So we know theta, we know the adjacent length, we're trying to determine the opposite. So we ask ourselves, which of the three trigonometric ratios uses opposite and adjacent? From before, we know the tangent of an angle theta must equal to the opposite length divided by adjacent length. So we were given the angle theta, 4 degrees. Opposite is the height of the woolly mammoth that we're trying to determine. And our adjacent length is our distance away from the woolly mammoth, 45 metres. So, trying to solve for opposite, we must make it the subject of the equation. We must get rid of this 45 To do so, we just multiply both sides of the equation by 45. Multiplying this side by 45 will cancel out a 45 from the denominator. So to evaluate the opposite, we simply to multiply 45 by the tan of 4 degrees. When evaluating the tan of 4 degrees, make sure your calculator is in degrees mode. So tan of 4 degrees times by 45 will tell us our opposite length of the triangle. So we've determined this opposite side, and consequently, we therefore determine the height of our woolly mammoth. So now let's look at another scenario. Let's say now while lying on the ground, you notice there is a stone lying on the ground directly in front of you. You crawl forward and you pick up that stone. Now looking up at an elevation of 6 degrees, you see the top of the woolly mammoth's head. We now want to know is how far I'm going to have to throw that stone to hit the woolly mammoth in the top of the head. So again, we have a right angle triangle. We know what this angle is. We'll denote that by theta. We've got a side length in our triangles. So is that the opposite adjacent or hypotenuse? So with respect to this angle theta, here, this is the opposite side. This is the length I'm trying to determine, the length that I need to throw the stone. That's the side which is opposite our right angle. So that's a hypotenuse. So, trigonometric ratio, which uses opposite and hypotenuse. Sine of an angle equals the opposite length divided by a hypotenuse length. So again, we know what our angle is, 6 degrees. We know the opposite length, that being the height of our woolly mammoth. And I'm trying to determine this hypotenuse length. So again, trying to determine the hypotenuse, I need to make it the subject of the equation. So what I'll do is multiply both sides of this equation by the hypotenuse. When I multiply this right-hand side by the hypotenuse on the numerator will cancel that one on the denominator. Solving the hypotenuse, again, needing to make it the subject of the equation, I must get rid of this sine of 6 degrees. Doing so, I'll divide both sides by the sine of 6 degrees. Dividing this left-hand side by the sine of 60 degrees will again cancel out with this sine of 6 degrees on the numerator. So I'm left with evaluating the hypotenuse, which is equal to 3.15 divided by the sine of 6 degrees. Again, making sure your calculator is in degrees mode. Evaluating that will give us 30.14. So therefore the caveman needs to throw the rock 30.14 metres to hit that mammoth on the top of the head. Now let's look at a third and final scenario. So in this example, let's say we have a flying fox which is located 10 metres above the ground. The total length of the flying fox to the ground is 50 metres. What we'd like to know is what is the total horizontal distance traversed by taking that flying fox. So again, in this situation, we have a right angle triangle. We're trying to determine an unknown side length, but we already have 2 side lengths given. So to determine this unknown side length, here we can apply Pythagoras' theorem. As mentioned before, Pythagoras' theorem tells us that the hypotenuse length squared must equal to the sum of the 2 other sides squared. So 50 squared must equal to our unknown length x squared plus our other side 10 squared. So we need to solve for x, make it the subject of the equation. I'll start by subtracting 10 squared from both sides. Evaluating this, so x squared is equal to 2400. To solve for x, take the square root of 2400. So therefore we know that the horizontal distance covered is approximately 49 metres. Now let's say we'd like to know what the steepness of this flying fox is. So what I want to do is to determine this angle theta. So again, right angle triangle containing an unknown angle theta. I'll label my sides as being either the opposite, adjacent or hypotenuse. So side opposite to theta is our opposite side. The side adjacent to our angle theta is our adjacent side. And the side opposite our right angle is my hypotenuse side. So I've given all three side lengths. I'm trying to determine this angle. Here I basically have the choice of three trigonometric ratios to use. Let's say for argument's sake, I decide to use cosine. We know the cosine of the angle theta must equal to our adjacent length divided by our hypotenuse. So the cosine of theta, the adjacent length, 49, divided by our hypotenuse, 50. Here we need to determine this angle theta from our given side lengths. Here we need to therefore use an inverse trig function. The inverse trig functions are sometimes also referred to as the arc functions. So here, to solve for theta, I need to take the cosine inverse of 49 divided by 50. So, evaluating this on your calculator, cosine inverse, or arc cosine, of 49 divided by 50 will give us 11.5. So the steepness of this flying fox is 11.5 degrees. So far we've defined the trigonometric functions as the ratio of sides of a right triangle. But not all triangles contain a right angle. These triangles are referred to as oblique triangles. So how do we solve such a triangle as these? Oblique triangles will require the use of either the sine rule or the cosine rule, depending on the information given. Thanks for watching.